Hey, from Tools. Hey guys, what is up? Welcome back to our weekly lesson. All right, today we are going into the next part of solution. Okay, if you still remember what we learned that day, okay, we have finished evaporation. Okay, very simple chapter. Okay, the four factors, if you still remember, and then we entered what is solute plus solvent, you get solution. Okay, and then you have dilute solution, the watery one. You have concentrated solution, the thick one, and then you have saturated solution, which is full. Okay, you have something you cannot dissolve. All right. Okay, today let's talk about what is solution, colloid, and suspension. All right. So as we have learned, we already learned solution. Okay, what is solution? You take salt, you add into water, you get solution. Okay, when something can dissolve in something, we call it solution. Okay, like when you dissolve salt into water, it's called a solution because the salt can dissolve in the water. All right, so let's look at what is solution. Okay, it is a clear mixture, very important. It is clear. Salt water is clear. Can you see salt inside? No, because it dissolves fully. That's why we call it salt solution. Okay, so there is no sediment, okay, which is the same meaning, no sediment. Sediment means something settled down. Like when your Milo, if you don't drink it for a few hours, okay, it has a thick layer of powder on at the bottom. Okay, that's why we call it sediments. Okay, it is homogeneous or uniform. Homogeneous means everything the same. It's not like here very dark color, here very light color. If you have a bottle of, let's say, mud here, mud water, after a few hours you don't kacau this thing, mud will be here. Okay, it will settle down here. Here will be clear. That's why it's not homogeneous. Color is different. Like Milo, if you don't stir your Milo for a while, this is very thick here, very sweet here. Okay, less sweet here. Not homogeneous. Okay, so homogeneous, salt water is homogeneous. Same color, when you drink it, bottom or up there, same saltiness. Everything is the same. Homogeneous. Homo means same. Okay, homogeneous. Okay, so uniform in color and appearance. You don't need to stir it. The thing is really uniform. Okay, it won't settle down. All right, so a size of particle tiny and dispersed evenly, okay, which explains why it is homogeneous. Okay, so dispersed means they are separated. Okay, evenly they are separated. Okay, so since they are clear, it allows light to pass through. When you shine a light into solution, light can just pass through as if nothing is blocking them, just like clear water. That's why we call it a solution. All right, and then no residue, okay, on filter paper. When you filter it, okay, you cannot filter salt out. Okay, no matter how good of a filter you use, you cannot filter them out. Okay, because they dissolve completely. Okay, like what? Salt solution, sugar solution. Okay, that's why they are clear in color. All right, very simple. Okay, let's look at the third one first. Suspension. Okay, what is suspension? Suspension is something that cannot dissolve in the solvent, like mud, like Milo, the one I talked about just now. So suspension is a cloudy mixture. Cloudy means it looks dirty. Okay, if you put mud into your water, it will look very cloudy. Okay, it doesn't look clear, it looks like you have color inside. That's why it's cloudy. Okay, and then because from undissolved solute particle, okay, you have undissolved particle inside. Okay, they are, you don't kacau them, they will sink to the bottom. Okay, like your Milo. Okay, and then it is heterogeneous. Okay, just now homogeneous. Homo means same, hetero means different. Okay, different. Sorry. Okay, hetero means different. That's why, like I said just now, if you have a mud water, here will be thick, dark color, here will be thin, light color. Okay, so not uniform in color. So particles are larger than those in solution. What is colloid? I'll talk about this later. Okay, it does not allow much light to pass through. Okay, because suspension, they are very large particle, because okay, they will sink to the bottom of the bottle, so they're very large particle, they can block light out. If your solution is very cloudy, a lot of mud inside, you cannot shine light through it. Make sense? Okay, make sense? Okay, residue is left on the filter paper, you can easily filter them. Okay, like what? Sandy water, because sand can sink. Mud water, mud can sink. Okay, oil shaken in water, water and oil will separate. Okay, and then blood. Okay, blood is also like that. Okay, that's why when you drink some medicine, okay, when you have cough or something, when you drink medicine, you can see on the medicine it says shake well before using. Why do they want you to shake? Some solution, some liquid they want you to shake because it's a suspension. Okay, suspension, it can sink to the bottom. If you don't shake, you just drink the one top here, you might not get any medicine, but at the bottom you get overload medicine, which is not good. Okay, so most they ask you to shake, just like when you drink your, before you drink your Milo, you stir it because you want equal sweetness. If you drink the top one, it's very bland, and then if you drink the bottom one, it will be super sweet. That's why you stir them, because it's a suspension. All right, so what about half? Some can dissolve, some cannot dissolve. We call it colloid. Okay, so we call it half. Okay, half of solution and half of suspension. It can dissolve, but it can only dissolve half. Okay, it's not as good as solution, but it's not as bad as suspension. That's why it's halfway. We call it colloid. Okay, two or more solute disperse evenly. Okay, and then same thing, it is homogeneous. Okay, the color is all the same. Okay, small and dispersed evenly. Okay, bigger than solution. That's why it's not as good as solution, but much smaller than suspension. That's why it's better than suspension. All right, and then light is scattered by particle. Okay, light still cannot pass through fully. It is scattered. Scattered means, okay, instead of going straight, it will scattered. Okay, just now suspension langsung cannot pass through. The thing will block. Okay, because particle too large, they cannot pass through. Okay, solution very simple, can pass through, but this one it will scatter. Okay, and then no residue. Okay, again you cannot filter them. Okay, like what? Cloud, smoke, shaving cream, milk, mayonnaise, jelly. Okay, these are all colloid. Okay, like milk, you don't need to shake milk. Okay, it's not mentioned on the carton says shake before using. No, you don't need to shake milk, but milk is not clear. That's why it's half. Can you see? Okay, that's why it's called colloid. So you have solution, suspension, and colloid. Okay, I hope this makes sense. All right, so let's look at solubility. Okay, solubility. So what is solubility? Solubility means how much can a solute dissolve in a solvent. Do you still remember what is solute and solvent? Solute is my salt, solvent is my water. All right, so what is solubility? The maximum amount of solute that can dissolve in 100 ml of solvent at a specific temperature. Can you see there are two CV here? You know, a CV, constant variable. Two things you don't change here. One, the volume of the solvent. It's set at 100, and the temperature. Okay, two things we don't change here. Okay, we set two things and then we see how much solute can dissolve. All right, so three factors here. What can affect solubility? How well can something dissolve? Okay, number one, size. Okay, so if it's fine powder, you can dissolve very well. Okay, if it's coarse powder, very hard to dissolve. Okay, why? Because smaller particles, smaller solid particles dissolve faster. They have bigger surface area. Okay, what do I mean? Okay, imagine now I have one big block of cheese. I want to cook this cheese. If I cut them into 4 small pieces, okay, who is going to cook faster, do you think? Okay, of course, these 4 small pieces, they are the same. Okay, I use this big piece, I cut it into 4, but the smaller one is going to cook faster because it has more surface. It has more surface area. Okay, this has how many faces? It has 6 faces. 1, 2, 3, 4, 5, 6. A square has 6 faces. But this one, 4 blocks. Okay, 6 times 4, we have 24 faces. That's why it can cook faster. That's why when you cut a chicken smaller, you can cook it faster. Instead of one big chicken you put in the pot. Okay, I hope it makes sense. Okay, that's why the smaller the size of the solute, the better you can dissolve. That's why fine salt dissolves faster than coarse salt. Do you know there's a difference? Okay, let's not talk about salt. Let's talk about sugar. Do you know there's coarse sugar and then fine sugar? Fine sugar is used to make dessert. Okay, because we don't want to taste the coarse sugar. Okay, we don't want to chew into something. We want everything to be smooth. That's why you have icing sugar. Okay, fine sugar. All right. Next, rate of stirring. Okay. Sorry. This is the picture here is reverse. So just change them. Okay. The faster you stir something, the faster it's gonna dissolve. That's why when you go kopitiam, they banjo the kopi, or you go mamak, they banjo kopi, you can hear the clack, 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 clack. Okay, why? Because I want to increase stirring so that you can dissolve faster. All right, so stirring makes solid particle move faster. Why? Because particle of solvent and solute fill up spaces between them faster. Okay, they can travel faster. That's why it dissolves faster. Okay, common sense. All right, temperature. That's the thing. That's why you don't make Milo with room temperature water. You can try. I've tried it before. Okay, worst idea ever, end up I pour the whole thing down. Okay, so of course higher temperature, faster it's going to dissolve. Okay, why? The particle of solvent and solid fill up spaces between them faster. So same explanation. Okay, same explanation here. All right, so 3 factors. Okay, just now last week the evaporation was 4, so now this is 3 factors. Common sense, if you ask me. It's like, how do you want to make a cup of Milo perfectly? Number 1, you use thinner powder. Number 2, you stir them faster. Number 3, you use hot water. Okay, simple. All right, so water as a universal solvent. Okay, water, we call it universal solvent. Why? Because it's the solvent that can dissolve the most stuff. Okay, most stuff on earth you can dissolve using water. Okay, it is known as universal solvent. Why? Because ability to dissolve almost all substance. Okay, and then use as solvent in domestic use, raw material in manufacturing industry. Okay, this is not important. Okay, so importance of water as a solvent. Why is it so important? Okay, digested food and waste product dissolve in water. That's why we can pee. Okay, we can urinate. Our urine contains 99% water. It carries the 1% rubbish out of our body. Okay, without water you can't pee, you can't throw the rubbish out. That's why the best way to clear your body from toxins, you don't need all these products or tea or whatever. Just drink water and sweat. The best way to clear your body from all these rubbish. Okay, so you don't need all these health products. Just drink water. Drink like 16 cups per day if you want. Okay, that will be very healthy. It make your skin better as well. Number 2, for plants, mineral from soil must be dissolved in water before the root can absorb them. Okay, that's why when you put fertilizer, if you don't water them, plant cannot absorb. They need water to carry the thing in. Okay, common sense. Okay, at home, water is used to dissolve cleaning agent, make drinks and cook. Okay, cleaning agents like what? Soap. Without water, soap cannot work. Okay, try to shower with no water and just dry soap. I'm not sure you can do it. Okay, so farmer dissolve pesticide in water because spraying them. Okay, simple. Okay, medicine prepare using water as solvent. All right, so common sense here. Okay, so what happens when water cannot dissolve something? We will use something called organic solvent. Okay, organic solvent. What are organic solvent? Most of these organic solvents, they are very smelly, very strong smelling. Okay, what are they? Let's look at them. Okay, organic solvents which are carbon based can be used to dissolve solids that are insoluble in water. That's what I said just now. Water cannot solve, you have to use this thing. All right, so they are very volatile. Okay, what does it mean volatile? Volatile means not stable, or which means it can evaporate, okay, easily. Okay, they can dry very easily, even faster than water. Okay, so what are the examples? Number 1, this is the solvent I love the most, alcohol. Not because I want to drink it, no. This thing is so useful. Okay, it can be used for anything. You want to remove oil. Okay, let's say your window is very oily, water cannot dissolve them. You just need alcohol. Okay, just buy 70% alcohol, get it from Lazada or something, put it in a spray bottle, you spray it down, one wipe and it's all gone. Okay, let's say now you have a price tag, annoying price tag here, you tear it, you have glue on it, so annoying, isn't it? Just use alcohol, wipe it. Okay, it will be gone. Alcohol can dissolve any oily stuff, and it is very volatile. It will evaporate very quickly. You wipe with alcohol, you wait for 20 seconds, this thing is completely dry. That's why alcohol is so great. Okay, so it can dissolve iodine, okay, scented substance. Okay, what is it used for? You don't need to memorize all these. Okay, just read a bit will do. Okay, antiseptics and disinfectant. Yes, and what is antiseptic? This means to kill bacteria. Have you ever taken injections before? Before they inject you, they will use alcohol and wipe here. Why? Because it can kill bacteria. Okay, very simple. All right, make perfumes and aftershaves. Okay, perfume contains alcohol. That's why you have the alcohol smell. All right. So turpentine and thinner, I'm sure you've heard of this, paint thinner. Okay, thinner you can get it from a hardware shop. Okay, this is to remove paint or to thin varnish. Varnish is paint lah. Okay, like your nail polish is varnish lah. Okay, if your paint is too thick, you want to water it down, you don't use water, you use paint thinner. Okay, very smelly. Okay, it can also use to remove your price tag as well, but this thing is very harsh on your skin. Okay, you use thinner, you will know, because your skin will get very dry, because not only it removes what you want to remove, it removes oil from your skin as well. That's why it feels dry. Alright, next, acetone. I'm sure girls, you have heard of this. Acetone is used in your nail polish remover. This thing is even stronger. Okay, the nail polish and lacquer. Okay, lacquer is paint lah. Okay, so nail polish remover, I'm sure you have used this before. One wipe and it's gone, and your nail feels dry. Okay, this thing is very strong. Okay, ether, I'm not going to talk about this. Benzene, chloroform, kerosene, you can just read it yourself. Okay, nothing important here. Okay, just touch and go here. Don't put your time on it. All right, so I hope I make sense here. Okay, so please know what is solution, colloid, and suspension. Okay, and what is solubility and the three factors. All right, so let's go into exercise. Okay, so if you still remember last week, we stopped some of the exercise because we haven't finished solution. Okay, now I think you should be able to do. All right, so if you want to do it yourself, you can pause the video here and then do it first, only we discuss. All right, so if you still remember, this is solute, okay, solvent, and then solution. What is the mixture? Okay, this mixture is a solution. Oops, sorry. Okay, sorry, I didn't read the question here. Add 2 spoons of sugar into a glass of water and stir it. All right, and then what is the mixture? I think there's something wrong with this question, okay, because in Malay it says flour. Okay, flour. If you add flour into it, this will become a suspension. Okay, this mixture looks cloudy. Explain why. Okay, because the flour particle, okay, cannot dissolve in water. Okay, it cannot dissolve. It just becomes smaller in water, just like your Milo. Milo doesn't dissolve in water. It just floats around the water. Okay, so that's why after a while it sinks to the bottom. All right, so mark for the correct statement and X for incorrect statement. Particle of suspension dissolves in liquid. No, okay, it doesn't dissolve. Particle of suspension can be seen by naked eye. Some, I would say yes. Can be seen by naked eye. Can you see Milo particle? Not really. Okay, particles of suspension are deposited when left to stand for a while. Correct. Okay, deposited means sink to the bottom. Okay, sink to the bottom. Oops. All right. Okay, so I'm sure you should be able to answer this. Okay, what is concentrated solution? Okay, the thick solution. Okay, it should be a solution that contains large amount of dissolved substances in it. So what is solution? Solution is a homogeneous mixture that is formed when substance is dissolved in another substance. Okay, so the point here is homogeneous. Okay, what is solute? Solute is your salt lah. Okay, so it should be a substance that dissolved in another substance. Okay, and then what is saturated solution? Okay, this should be this. Okay, a solution that contains the maximum amount. Okay, saturated means full. What is suspension? Suspension should be this. Okay, a non-homogeneous mixture that contains insoluble. Okay, that's why can you see it's not soluble. So what is solvent? Solvent is a substance, usually a liquid, that dissolves other substances. Okay, what is dilute solution? A solution that contains small amount. Okay, the watery one. Okay, I hope this makes sense. I hope you know how to do this. This is basic concept. All right, underline the correct answer. The higher the rate of stirring, the higher the rate of solubility. The more I stir, the better it dissolves. The size of particle, the higher, so the smaller. Okay, remember, fine sugar dissolves better. The higher the temperature, the higher the rate of solubility. Okay, you make Milo with hot water. Okay, so this is solution, suspension, or colloid. Okay, so this is paint. Okay, paint should be a colloid. Okay, why do I say so? Because this is not clear, but this doesn't settle. You don't need to shake your paint. Okay, and then for orange juice, this should be a suspension. Okay, that's why when you don't stir it, all the pulp, okay, the meat of the flesh of the orange will sink to the bottom. Okay, shaving cream is colloid. Okay, this is sugar water. Okay, sugar water should be solution. Okay, so match the following to the correct type of compound. Salad sauce is colloid. You don't shake salad sauce. Okay, do you shake Thousand Island sauce? I don't think so. Okay, apple juice. Apple juice should be a colloid. Because it's not exactly clear, it's yellowish. Okay, blood is suspension. Okay, carbon dioxide in water. This is a very weird example. Okay, can carbon dioxide dissolve in water? So I would say it's a colloid. Never mind, we skip this first. Okay, mixture of water and chalk. Okay, of course this is a suspension. Milk is colloid. Okay, vinegar. Okay, vinegar is a solution. That's why vinegar is clear. Have you seen vinegar before? Vinegar is clear. Okay, it's like water. Okay, so carbon dioxide and water. Let's just assume it can dissolve in water to form carbonic acid. Okay, I would say this is solution. Okay, this is not your syllabus though. Alright. Alia carried out an investigation to study the type of solution formed when the solution dissolved in a solvent. She found that 3 spatulas of salt produce a saturated solution dissolved in 50 ml of water. Draw the particle of salt water produced when 1 spatula is added. Okay, so 3 makes saturated. So 1 spatula you get, I should say, diluted. Okay, so it should look like this. The particle, they just want the particle. So you have the water particle. Okay, you have water particle. Okay, so and then you have salt particle. Okay, so not so much because this is diluted solution. 5 spatulas. Okay, so 3 is full. 5 of course is super full. Okay, so just draw a lot of salt. Okay, just draw a lot of salt. Okay, and then some water particle. Okay, this is a very weird question. Alright, does heating the water increase the rate of solubility? Okay, I would say yes. Okay, it means faster. Doesn't mean I can dissolve more. It means I can do it faster. Yes, okay, because salt particle and water particle, okay, can move faster, okay, to fill empty spaces between them. Okay, this is in the notes. They can fill it faster. Okay, dissolving something means I need to fill this thing between the gaps of 2 things. Okay, I need to fill the salt particle in between the water particles. Okay, that's what we call dissolving. So Mary added 2 spoonfuls of salt to 50 cm³ of water in beaker A, 2 chalk powder to 50 in beaker B. After stirring, she left the mixture for 10 minutes. Okay, so as you can see, this is a solution. Okay, and as you can see, this is definitely a suspension. Okay, because chalk cannot dissolve in water. Okay, what changes in beaker A? Okay, so you can say clear solution. Okay, clear solution produced. Okay, don't say mixture, say mixture lah. Okay, clear mixture. Okay, so B, this is a cloudy mixture. Okay, it looks cloudy, dirty. Okay, Mary thinks that the big mixture in B is a suspension. State 1 test you should carry out to confirm. How do you know this is a suspension? Very easy. Shine a light through it. Okay, shine a light through it. Okay, light will not be able to pass through. Okay, simple. Okay, C, you are required to distinguish means to differentiate between 2 unknown substances blindfolded. You were told that the two substances are a mixture. Okay, so they could be solution, colloid, or suspension. What are the questions you should ask to identify the type of mixture? Okay, so how would you know? You cannot do anything. You are blindfolded. You can only ask questions. So what are the questions you should ask? Okay, does the mixture settle? Or okay, does the mixture have sediments? Okay, sediments means what sinks at the bottom. Sediments after left to stand for a while. Okay, so what else can you ask? The light one. Does light Okay, pass through it. Okay, what else can you ask? Is the mixture clear? Okay, can you see through it? All right, so 3 questions you can ask. All right, so the video I think is a bit long. Never mind, I'll make this video longer. Okay, so you can do more questions at home. All right, compare and contrast 3 types of mixture, solution, suspension, and colloid using the chart below. Okay, so solution has A and G, smallest particle size, and G is not mentioned here. Oh, so all these underlying ones, they want you to answer L, K, G, J, I. So what is G? Okay, G, only for solution. Can you see? This is only for solution. What is only for solution? Can be separated by filter paper? No. Scatter light? No. Does not scatter light. Pass through filter paper. I would say does not scatter light. Okay, because if light can pass through it, not scattering, confirm this is a solution. Alright, let's look at H. Okay, H is between colloid and solution. What do they share? I think the answer should be this. They can pass through filter paper. Alright. Why would I say so? Because you cannot filter shaving cream. You filter shaving cream, you don't get anything, okay? Because it's something like a solution, okay? But it's not clear like a solution. That one is halfway, like I said. So what is I? I is only for colloid. What is for colloid? Colloid I should be this, scatter light. Okay, because for solution doesn't scatter light. Solution will let light pass through. Suspension will block light, not scatter. Okay, how about J? J is between colloid and suspension. I would say this is scatter light. Okay, sorry for this. Okay, because there's no block light here. So I would say the closest answer is scatter light. So how about I then? What is only for colloid? I think it's this one. Okay, medium particle size. Okay, how about K? K and L is only for suspension. So we have only 2 left over. So can we verify them? Largest particle size, yes. Okay, largest particle size. I think you can write this for L. L can write for K. They are interchangeable. What else can be separated by filter paper? Okay, so finish this yourself. Give an example. So salt water suspension, mud water, okay, colloid, shaving cream. Okay, I think I will stop here. This is getting a bit too long. You can finish this yourself. Okay, don't worry, I'll upload the answers. Not much left. Like this is 2 questions left. Okay, 3 questions left. All right. So I hope I think this is enough to keep you busy for the next coming week. All right. So I hope this video makes sense. I hope you learned something today. Okay, I would say this part is the most easy part to score and the part that is asked the most in exam. Okay, so make sure you spend enough time on it. Alright, so next week we will go into the last part of this chapter and we should be able to be done with this. Alright, so spend more time in this chapter. Make sure you master it. Okay, I will see you again next week. Stay safe and bye-bye.